Hey guys, so this is going to be a review of systems of equations. So I'm not going to be going into as much detail as some of my other videos, but hopefully this will jog your memory of systems of equations and let me know if you have any questions. All right, so first of all, remembering that a system of equations is when we have two or more equations. In our case, it's always going to be two. And then if an xy pair, if you plug in the first number for x in each equation and the second number for y in each equation, and they are both true. So in this case, when you put in 1 for x, you get 5 here, right? 5 times 1 is 5. Put in 1 for y, 4 times 1 is 4. 5 minus 4 is in fact 1. So you get 1 equals 1. That's true. And then you'd have to do the same one here. So y is 1. So 1 equals 2 times 1 minus 1. Well, 2 times 1 is 1, minus 1 is 1. So on this side you get 1, and this side you get 1. 1 equals 1 is true. So 1, 1 is in fact a solution to this system. So the point is, for something to be a solution to the system, it has to be true for both equations. All right, so let's talk about graphing. So if I am just given a solution and asked to, if I'm given a system, and I'm asked to find the solution to the system by graphing, then I have to graph each one separately and then see where they cross. The point where the two graphs cross is my solution. So remembering that when we're graphing linear equations, this is the y-intercept and this is the slope. The thing with the x is always the slope, and then whatever is being added is the y-intercept for linear equations. So my y-intercept is 3, and my slope is 2, so I'm going to go up 2 over 1. So if I go up 2 over 1, and then if I'm doing this by hand, I would go up 2 over 1, put a dot there, and then go the other direction to get this part. So I would go down to left 1. So if I'm going up to right 1, then this direction I'm going to go down to left 1, the exact opposite. And I would put dots in here, and then I would draw my line through all my dots and put arrows as well. All right, so then for the second one, my y-intercept is 3 again. So I'm going to put one of these at 3, and my slope is -3. So I'm going to go down 3, 1, 2, 3, right 1. So it's negative, so I'm going down and to the right. It's up and to the right, it's down and to the right. And then so I'd go down 3, right 1, down 3, right 1, down 3, right 1. And then to go the other way, I would go up 3, left 1. So just doing the exact opposite of what I did in this direction. My solution is the point where they cross. So in this case, that would be 0, 3, right? X is 0, y is 3. So this is 0, 3. So that would be my solution. What I put here would be 0, 3. Okay. So that's graphing. So remember that if you have this situation where they're parallel to each other, that's going to be no solution, because no matter how far these go, they're never going to cross. This, where they cover each other up, would be infinitely many solutions, because no matter where you are on these lines, they are the same. They're the same equation, essentially. One more thing I want to talk about. If I have this situation, that would be y equals 3 is the equation of this line, because you're going through, no matter where you are on this line, y is 3, right? if it's vertical, if it's like this, which Khan Academy won't let me do, but if it's vertical, if it went through those two dots, that would be x equals 3, because here x is 3. All the way along this line, x would be 3. Okay, so let's go on. Okay. Okay, so let's talk about substitution, solving with substitution. So that means I'm going to take one equation and I'm going to substitute into the other equation. So to do that, I need to get one equation so that it's either x equals something or y equals something. In other words, I need either x or y by itself on one side of the equation. In this case, they already have it solved so that x is by itself. So I can just plug y plus 3 in for x. So what I mean by that is I'm going to say 6, and then instead of x, I'm going to put y plus 3, which I can do because x equals y plus 3. So it's equivalent, so I can replace this x with y plus 3. And then I'm going to do 5y equals 15. And then I'm going to distribute this 6. So distribute the 6. I'm going to get 6y plus 6 times 3 is 18 minus 5y equals 15. Then I'm going to combine like terms. So I have a 6y and a negative 5y. So I can combine those. So 6 minus 5 is 1. So I just get 1y, which is the same thing as y. Y plus 18 equals 15. And then the last thing I need to do is subtract 18 from both sides. 15 minus 18 is negative 3. So I get y equals negative 3. So that's y. That's my answer for y. And then to get x, I just plug this into this original equation, x equals y plus 3. So x equals negative 3 plus 3, x equals 0. So now I have that information. I need to write these as a coordinate pair. If you're doing it in Khan Academy, you just put x here and y here. But on, say, a test or a worksheet, you would put it as a coordinate pair. So 0, negative 3. Remember, in a coordinate pair, it's always x, then y. So this would be how you would write your solution, 0, negative 3. Okay. So that you won't always be given something that is already solved for x. So say they had given it to you as, let me do some erasing so that I can write more things. Okay. So say they had given this second equation, say it had been x minus y equals 3. But I had been told that I need to solve by substitution, and this equation is the same. I would need to solve this for either x or y before I can substitute it in. So I could add y to both sides, which would give me this, and then solve it exactly the way I just did. Or I could get the y by itself. So I'd subtract the x. So I'd have negative y equals 3 minus x. And then I have to get rid of this negative. So I'm going to divide by negative 1. And so I get y equals negative 3 plus x, or y equals x minus 3. Would be another way to write that. It's the same thing, I just don't like having a negative in front. So y equals x minus 3, and I could plug that in here instead. So basically, you can either solve it for y or x, and then whichever one you solve it for, you can just plug it in the appropriate place. Yeah, okay. And like I said, you may not be given something like this, so you may have to do the rearranging and then plug it in. All right. All right, let's talk about the third way to solve a system, which is to solve using elimination. So when we say we want to use elimination, that means we're going to add these two equations together in such a way that gets rid of one of the variables. So in order to do that, we need the coefficient, the thing in front of one of the variables, to be equal and opposite of the coefficient in front of the other variable. So there are a couple ways that I could do that. I could try to get the coefficient in front of the y's equal and opposite by multiplying this whole equation. Remember, when you're multiplying, you have to multiply the whole equation, not just part of it. Multiplying the whole equation by 3. So then I'd have a 15 here, and then multiply this equation by 5. So then I would have a 15 here as well. So then I'd have 15 and negative 15, and when I add those together, I would get rid of that y term, which is what I want to do. But the easier thing to do would be to multiply this equation by negative 7, because then this would be negative 14. And then I only have to multiply one equation, not both. So you have options, but the easier option on this particular equation would be to multiply this equation by negative 7 so that I have negative 14 here, which matches the 14 here, and then I would be able to get rid of the x's. So that would be what I want to do in this case. The fewer amount of steps if I do that. So let's do that. So we're going to multiply this whole thing by negative 7. So I get negative 14x plus, remember it's negative 7, so negative 7 times negative 3 is positive 21x, positive 21y equals negative 29 times negative 7 is going to be positive 203. Positive 203. And then I'm just going to rewrite this equation here so that I can add them together. So I'm just adding them together. So we have 14x minus 14x is 0, which is what I wanted. That was why we multiplied by negative 7 in the first place. 5y plus 21y is 26y. And 31 plus 203 is 234. So then I just need to solve this to get y. So all I have to do here is divide by 26. Divide by 26. So I get 234 divided by 6 is 39. So I get y equals 39. That would be my final answer for that. And now I need to get x. So I can plug the y that I found into either one of these equations and then just solve for x. So I'm going to plug into this equation because it's got smaller numbers. So the math will be a little bit easier there. So 2x minus 3 times y is 39. So that's where I'm going to put my 39 equals negative 29. Negative 3 times 29, not 29, 39. Sorry, there's a 29 in the problem, but not there. Negative 3 times 39 is negative 117. So I have 2x minus 117 equals negative 29. So I need to add 117 to both sides. Oops. So negative 29 plus 117 is 88. I'm going to erase this earlier step so that I can continue. Okay, so I have 2x equals 88. Divide by 2, divide by 2, x equals 44. So that would be my final answer, x equals 44, y equals 39. So remember that I write that as 44, 39. That would be my coordinate pair. That's my answer right there. So that's kind of a crash course in solving systems by graphing, elimination, and substitution, not in that order. In the next video, I'm going to be doing a review of graphing inequalities.